Alright, so I actually did this one yesterday, and my microphone wasn't working. It had a buzzing noise in it. It just happened in the past, and I finally fixed it, I think. So, I'm going to do it again, but I'm going to do a better solution. I'm going to keep this part here. So what we're doing is my square root, which is just take the square root of a non-negative integer and then round down to the nearest integer, and the returned integer should be non-negative as well. Yeah, so this is a searching problem. You can brute force it between 1 and half of x, which is what I did in my 2 solutions ago, or what you can do is a binary search. So a binary search is what we're going to do. We'll take the example of 8. So we're going to start with our left pointer at 0 and our right pointer at 4. And we know that it can't be more than x floor divided, just because the properties of a square root, being that I think it's after about 2. Like 4 times 4 is going to equal 16, which is obviously way higher than 8 because we're looking for 2. So what you do is, this is our left pointer, this is our right pointer, and then we set a mid pointer here. We check, is 2 times 2, which is 4, less than or equal to the target or greater than? That's obviously less than. 4 is less than 8. So you set this pointer here equal to 3. Then we're going to get 9, which is going to be greater than 8. So we're going to return, that's going to be greater than, which will move our right pointer here. Then we have our condition, which is while left is less than or equal to right. This will break it, and we return right pointer at the end. Because we're floor dividing. If we were ceiling dividing, we'd take the left pointer at the end. Sorry, we're rounding down. We're not rounding up. So what we're going to do is while left is less than or equal to right, if mid is going to equal left plus right on 2, then what we're going to do is if mid times mid is equal to target, we return mid. Wait, what's target here? Equal to x. If mid is less than x, if mid is less than x, which is 4, we're going to do, if mid times mid is less than x, we're going to do left plus equals 1. Else mid times mid is going to be greater than x, we do right minus equals 1. And then, like we said before, we return r. And this should work, I hope. I think I might have caused an infinite recursion. Wrong. Okay, output 4. Typically, you would return the left. So maybe I was wrong here with returning the right. I actually don't really see why that doesn't work. I feel like it would left plus equal. If 4 is less than 8, which is 2, we need to do left plus equals 1 to make it bigger. Oh. Okay. It's left equals mid plus 1. And right equals mid minus 1. You don't add 1. Oh, whoops. Alright, there's no need for this to run for this long. It's there's no return. See if this works now. Time limit exceeded. That doesn't seem right. Why is that a 1? Did I click a 1 instead of an L? Well, that's a bit of an annoying bug, but it works. So that's how you do the square root. Typically you'd want to return the left pointer with a binary search in problems I've done so far. For this one, because we want to go down, the right pointer is needed. So that's cool. Yeah, that's the fastest solution, I believe.